After creating the structural model in Revit, we are now ready to transfer the data to our analysis software. This is a big part of the BIM process, since you don't have to remodel the structure in your analysis software. You can simply transfer this data and no data loss will occur. In order to do this, you will need the Prodesk tool, which was developed by Prokon Software Consultants. This tool, as we've shown before, will allow you to load sections from the Prokon section database into Revit, but it also allows you to export, import to Frame and Sumo. To demonstrate this, I will select the entire model. You can also do this level by level. I'm going to go to my Prodesk tool and choose the Sumo export. Various features are available in the export. You can choose to use selected elements or selected levels. You can also choose to convert non-structural walls to line loads. If any other elements is available, for instance stairs or ramps, you can convert them into plain shells. For this specific example, I'm going to generate my Sumo model. Once the export is complete, you will then have your complete model inside Sumo. Not only did the model transfer, but you will notice in the table input that all the data that was set up in Revit have transferred as well. Because I have used the sections from the Prokon section database, those sections was automatically transferred, including the material. Also, if we look at load cases, in this example, all the load cases was transferred to Revit, but I can then go and individually delete the load cases that I do not need. It is important to know that modeling can be done in Sumo as well. Obviously, as part of the BIM process, you would like to do as little remodeling as possible. This is why we transferred this model from Revit into Sumo. But to demonstrate that modeling can be done in Sumo directly, I will add my intermediate beams directly in my Sumo model. You will notice that the levels from my Revit model was transferred as well, so I will use very much the same process as I've done in Revit. I will go to my roof plan and I will start placing my individual beams as I require. Once complete, I can view my model in 3D again, make sure that all the elements are connected. If you would like to view your model with the node points, you can switch to a desktop view. And as you can see, Sumo automatically generates the node points from the Revit structure model. To demonstrate this powerful feature, if I add another element to my Sumo model, you will notice if I add an element from, let's say, this point to that point, Sumo will automatically generate nodes wherever there's an intersection between two elements. One can also disable this feature by switching off the auto split functionality. However, the beam element will still have a start and end connection. For the next part, I will add some loads before we can analyze the model. In my load cases, I've already got my dead load and live load created. To add another load case, I will simply click on add and I can set it up exactly as I want to. I can also choose which load case will be the self weight of my structure. In this case, I will use the dead load. In terms of load combinations, we can also set up load combinations. For instance, in this one, I've created a load combination 1 between my dead load and my live load. I can also go and add my safety factors, which will then automatically calculate those for me. Once I'm ready, I can then start placing my loads on my structure. For example, if I want to add live loads to my slab elements, I will simply go to the Loads tab, choose my slab distributed load, choose the load case that I want, and by simply selecting the slab, it will place those loads on the element. The same principle applies to beams. I can, for instance, add a UDL beam load, and in this instance, I will manually create the load from point to point. The reason I'm using this specific method is to demonstrate that loads in Sumo can also be copied. I will change my load gate. Once I'm ready, I can then simply copy that load across to my other beam elements by using the copy, array, mirror, linear, etc. Once all my load cases have been added, we are now ready to analyze. Before we run our analysis, you will notice in the Output tab, there is some error messages that we need to attend to. For instance, when an error message is critical, it means that we cannot do an analysis. If it's a normal error, you can ignore it, but you will not get the results you are looking for. In most cases, you'll see that I've got my foundations that has not been assigned a material. So I can simply select the entire model, filter out my foundations, and assign a material. Once I've done that, you will notice that all those error messages will disappear from my list. The last three messages all points to my slab elements not being meshed. If you don't know where the element is, you can click on the Find button. It will highlight the element and it will allow you to mesh or make changes to that element. If I want to change my mesh size, I can simply do that in the properties, click the mesh button, and it will automatically mesh my elements. And I can do this for each one of the slab elements. Alternatively, like we've done before, we can select all the elements, filter out all the slabs, and do it all at once. In this case, because my mesh size is different, I will change it for all of them, mesh them, and to view the mesh, we can simply click on the Destrotize view, and you will notice your finite element mesh. Also notice that there's no more error messages, which means we are now ready to analyze our model. Once we have done all the modeling and the loads, we can then go to the Analyze tab and solve the model. After the analysis, we can then go to the Results tab and view various results. You will notice in the ribbon there's displacement, reactions, beam, shells, and also composite results. For instance, if I would like to view the reactions in a certain direction, I can simply choose in the ribbon exactly what it is I want to view, and those values will be displayed on my model. I can also create a screenshot for my design report purposes by simply clicking on the Report button. Other elements that can be viewed or other results that can be viewed, for instance, if you would like to view your reinforcement requirements, you simply choose the values that you want to see, and those values will be shown on your visual results. Once again, if you would like to add this to a report, you can click on the Report button and it will send that to your design report. At the bottom left, the Report tab I can open, and you will notice those images that I've created. I can also view my results in a tabular form. You can choose the results you want to view. For instance, if we want to look at the reactions again, but you'll see there's a lot of values that we have to consider. If you are only interested in certain values, you can also filter out. For instance, if I'm only interested in reactions that is bigger than a certain value, I can just go and define that in my filter and it will give me those values. I can also sort values from smallest to biggest, and I can then add that to my design report. The design report is a Word component, so it can be exported to Microsoft Word, or alternatively, you can make additional changes directly in the report. It works exactly on the same principle as your word processing software. The last part of the results I would like to show is the charts view. The charts view is an extremely powerful feature because this allows you to look at your results graphically. For instance, if I would like to look at some of my beam bending moment or shear force diagrams, I can simply select an element, choose a load combination or a specific load case. In this case, I'll choose combination 1, and then I can also choose the results that I would like to view. As you can see right now, I'm viewing that for all three, and then you can then start looking at your critical values, and again, this can be sent to your design report. Sumo also contains all the design modules that you are used to in frame analysis. In the Design Links tab, you will notice that all the modules are available. When you're ready to design your structure, you can simply select the elements you want to send to your design module and open the design module that you want to use. And this will automatically then send this information for your design. Once you have done your design, if there was any changes and you save the design file, that information will automatically be imported back into Sumo and it will update your model.